session, I'll talk about the neural networks that actually it use the concept or capture the idea from our brains. In our brains, there are many neurons. In our textbook, the neurons, this one, connect to each other like this, and it can connect to other neurons also, and can connect to more than one neurons like this, and this one can be connected from the other neurons like this also. Okay, this is the network of the neurons. Neural networks capture the idea from this structure. For the structure of the neurons, actually, this one is neurons. In our brain, there are around approximately 10 power 10 to 10 power 11 neurons. And each neuron connects to other neurons by this 10 power 4 to 10 power 5 for each neuron. For each neuron. So you may see that for one neuron, the connection to other neurons is like 10 power 4 to 10 power 5 connection. So you can see that is like a huge, very huge system, right? So I think our brain is one of the things, the wonderful, in my opinion, it is the most powerful computationable cell. It's like the huge system that for even some computer it cannot imitate, because the computation is like this, and for each neuron it can process the signal by itself. So in our brain, it's like a huge parallel computing system. This is very, very wonderful. So guys, you are one of the most wonderful things in the world. That's your brains, and your body is also in the neurons, in a neuron, it receives the input signal from other neurons like this, and once the signal is like greater than some threshold, like the amount of the input signal is sufficient to trigger the neuron. This neuron will send the output to other neurons if it is fired or activated. In this case, the amount of the input signal must be sufficient, like greater than some threshold. So if we want to capture the function of the neuron into our system, the idea is like we can create a computational model that imitates the function of the neuron like this. If you have a neuron like this, an artificial neuron like this, sorry, to have, okay. So it must get the input from other neuron and sum the amount of signal. And if the amount of input signal greater than some threshold, it will fire and send the output to other neuron. So in the real world, the link to each neuron have different importance. So maybe these two neurons is important, but this one is not so important. The weight here should be less than the weight from these links. So in our nodes, you should have different weight. And if you name it like this one is x1, x2, and xn, so you have wi, w2, and wn. So we can write a simple equation that for this part, the summation part, this one, the output of this part is y is summation of wi times xi for all I, or for all I is I is I to n. So if this y is greater than some threshold, it will give the output to be 1. If y is greater than b, to be 0 otherwise. So the output occurs here in this part to check that the summation is greater than the threshold or not. And the summation in this part occur here. Okay. So guys, if I combine two equations together, so finally, if wixi summation of wixi when I is 1 to n, it must be greater than b when b is a constant. So this one is like w1 x1 plus w2 x2 plus wn xn greater than b, right? So we can move b from this part to this. So it will be minus b plus wixi plus w2x2 plus wnxn greater than 0. And minus b is a constant. So you can replace minus b by some values like w0 times x0 plus wixi plus w2x2 plus w until wnxn is greater than 0 when x0 is 1. Okay, so we can group the left part of your equation to be summation of I is 0 to n wixi greater than 0. Someone say greater than or equal. Actually, the one that I like is greater than 0, not equal. Okay, so this is a basic equation of a neuron. Now we have the names for this neuron. This is a perceptron. Okay, so The perceptron will get the input from various x on this side and send along the link that has different importance. The importance is represented in the terms of W, the weight. Once you can combine it, once you can sum the product of Wixi, W2x2 until Wnxn, and you can sum it together, you have to check the result to be greater than some threshold or not. So the final equation will be this one. In the next video clip, I'll use this equation to find some operation that you're familiar with. Okay guys, see you in the next video clip.